Alright, this is our second lesson, and this is a lesson in areas. And one of the most important jobs of a surveyor is being asked to calculate the area of a given place, a given parcel of land, or a given area about to be constructed on, setting building corners, etc. And one thing that surveyors have over all other professions is the ability to measure things and to locate things on the ground, either where, say, a property corner is or where a building should be. So this is where you learn the basics. If you know your units of length and conversion factors and all that, we can move on into the areas. Easiest area is that of a rectangle, and that's all a rectangle is four-sided figure with four right angles, and it's the length of one side by the length of its adjacent side. Base times height, however you want to say it. Not complicated. So if you have a rectangle which is 75 feet by 150, it's 11,250 square feet, or 0.258 acres. And an acre is 43,560 feet. Burn that figure into your memory. You're going to need it. Now, the area of a circle. Like the old joke, pi r squared, no pi r round. The area is pi, which is the relationship between the circumference of a circle and the diameter of the circle. So there's circumference divided by the diameter, which looks amazingly like the Greek letter theta, and why it's not called theta, I have no earthly idea. But anyway, it's pi. One of the most useful concepts that you will ever see or get to work with. So anyway, to figure the area of a circle, if it has a 75-foot radius, then you multiply, you square the radius and multiply that by pi, and you have 17,671.45 square feet. Couldn't be any easier. And any section, any part of a circle, if it is bounded by two radii, is just a percentage of the area of that circle. So if this is a third of a circle, it's a third of 17,671.45 feet. It's very simple. Don't make it any more complicated than it has to be. Now, the area of a right triangle. Much easier to draw than it is to explain. A right triangle has a right angle. So it's easy to say base times height. The area of a right triangle is simply the length of the two adjacent sides that are around the right angle. And it's very simple. It's also half of the area if this thing would have been a real rectangle. So it's not rocket science. All you have to remember is this is the hypotenuse of the right triangle, and these are adjacent and opposite sides depending on which angle you're looking from. And it's adjacent times the opposite over 2. That's it. Now, two very quick asides here. How do you know if it's a right triangle if all you can do is measure it? If you can't actually set up and turn an angle with an instrument? Well, if the relationship between the sides, for instance, is, that's a right triangle. Not all right triangles have that ratio, but you can use the 4-5-6 formula if you're measuring along these lines and can measure from there to there. You can determine if you do have a right triangle. A simpler way to do that is to measure all three sides. It's a little bit more complicated in terms of the math, and square the length. So you add 4 squared plus 5 squared And if it equals the length of this side squared, then you have a right triangle. And it doesn't get any easier than that in terms of the concept or doing it. So there are many times that you can do very surveyorly work with nothing more than a tape measure. I have, and it has saved my cookies any number of times just knowing how to work with the Pythagorean theorem. Now, let's get to a triangle that is not a right triangle. That's not a right angle, so anyway, we're going to say that this is 60, and you will discover that I can't draw worth a flip, so don't worry. This is 40, and this is 30. What's the area? All you have to do to find out is the formula is it uses what's called the S factor, and the S factor is the perimeter divided by 2. So 60 plus 40 plus 30 is the perimeter, the length of all of the sides. So 130 over 2 is 65. And this is going to be the square root of 65 times 65 minus 65 times 65 minus 40 times 65 minus 30. So when you do all of that, you end up with the square root of 284 squared, foot squared, which gives you, if you're thinking in terms of acres, no, it gives you 533 square feet, which is a very small portion of an acre. So it's a very simple means of measuring, and it used to be that surveyors chained a lot of distances to measure areas. And I have a book from like 1740, and that's how they measured. It was a very rough job back then. You spent a lot of time in the mud, but then if you've been a rodman in Texas, you know what working in rough country is like. Now, we have the oblique triangle. We've already done that. What about a trapezoid? Trapezoid is any closed figure like this where you have two parallel sides and these two sides are not parallel. It's not that complicated. How do you figure the area? Well, first you cheat. You measure the distance between these two lines, and we'll just say that that's 5 feet. And then we'll say that we'll call this 12 and we'll call this 8. So what's the average of 12 and 8? That's 10. So 5 times gives us a cross-section area of 50 square feet. It's very simple. You just have to be able to calculate or measure. Get down there with a level rod or whatever you need to do. You can calculate it by making that a right triangle, but we haven't gotten that far yet. So the area of a trapezoid is the average of the base and the top times the height. Another way of doing it is sort of the way that your calculator does it. For a very complex figure, break it down using graph paper or mathematics. You can do that, but in any event, just break it down into simpler figures and calculate the area for that. So our basic units of measurement for area, at least in the United States, are 1 acre is 43,560 square feet. 1 square mile is 640 acres. And a hectare is 10,000 square acres. So that's not used very often by surveyors, but it is used quite a lot by government agencies, because everybody wants us to start using meters. It actually is a simpler system, but I certainly don't think in meters. So anyway, that's it on our quick lesson on calculating area, and we'll go on to volume next one.